Okay, so in this video, I'm going to be finishing the second part of the final exam review. I got cut off on the first part because of my newborn. So my husband's watching him for me, so I will definitely be able to finish it. So for we left off on number 16, and I am starting with number 17 here. So number 17 says to write the following equation in logarithmic terms. So this is in exponential form because it has an exponent. So exponential form in the general form equation is a to the x equals b. So this is exponential form. And we can always go from exponential form to logarithmic form and backwards also by using the logarithmic form, which is log base a of b equals x. So this is called logarithmic form. So what this means is that if I have something in exponential form and a is the base of my exponent, then a will be the base of my log. And whatever the exponential form is equal to, which is b here, this will be the expression inside of my log, and then the exponent is always equal to the log, because that is what a log is. It's equal to the exponent that you need to raise the base to in order to equal the expression inside the log. So in this example, the base of the exponent is 7. Oops, let me get the right thing here. So that's technically my a in this exponential form up here. So that's going to be the base of my log. So I would start with the base. You always start with the base. It'd be log base 7. And then whatever it's equal to, which is 343, that's my b in this form up here, because that's what it's equal to. That's going to go inside of the log expression. And then this will be equal to the exponent, which is 3. So you can write all of this on your flashcard. And this is the answer. That's all they're looking for. They're not really wanting you to solve anything because it's technically already, there's no variables in this equation. They just want you to write it in the logarithmic form. So that would be the correct answer. Number 18 says to use the elementary properties of logarithms to solve the following equation. Write your answer as a fraction reduced to lowest terms. So now they actually want me to solve an equation, and this is now the logarithmic equation because it's in logarithmic form since there's a log. So what we're going to do, if you have a logarithmic equation in this exact form here, which it is, has a log base 4 of 7x and it's equal to 2. So it's in that form. We can rewrite it in exponential form, and then we will be able to solve this equation. So in this equation, the base, let me zoom out a little bit. The base is 4 here, so that will be my a. The expression on the inside is 7x, So that is my b. And 2 is what the log is equal to, so that will be my x. In terms of this form is what I'm talking about when I say it's my x. So I'm highlighting it in the same colors. So I can rewrite it. So again, I start with the 4, that's my base. It's raised to the power of 2, and then it's equal to 7x. So I'm just putting it back into its exponential form. Using colors to show you what I mean. This is the exponential form that I had written up here. So now I can actually solve this because 4 squared is 4 times 4, which is 16. And then to finish solving for x, we divide both sides by 7. So the final answer is x equals 16 over 7. That cannot be simplified any further. Number 19 says to use the properties of logarithms to expand the following expression as much as possible. So these properties of logarithms are properties that allow us to rewrite certain logs. So I'm going to write what they are here. So the first one is in log and ln. It works with both. Ln is the natural log, and ln always ln, let me just write this rule too. Ln of x is the same thing as log base e of x. So the rules for these logarithms is if I have log of a times b in an expression, this can be expanded using summation. So this would be log base a plus, or sorry, log of a plus log of b. And if I have log of a divided by b inside of an expression, this is separated using subtraction. So this would be log of a minus log of b. And if I have log of a raised to the exponent of b inside of a log, this can be expanded by pulling that exponent of b out front, and it gets multiplied by what's left, which is log of a. So these are the 3 rules that you can also have on your flashcard here. Now the first one you want to always use if it's in the expression is the division. So that's this one here, the second one. So we have division, a fraction, in our ln. So the first thing I'm going to do is to rewrite this, taking everything in the numerator. So ln of 4x to the 6th power, and then subtracting ln of everything in the denominator, which is y to the 4th. So you can see I'm using that property there of division and expanding it using subtraction. I keep the log or the ln, and I take the log of the numerator and I subtract the log of the denominator. So that's the property I used there. And I always remember that there's a line in the fraction and there's a line in subtraction. The next property we want to use is the product rule. So if you have anything being multiplied inside of these ln's, and all of this is contained inside the ln, by the way. So in the first one, I have 4 times x to the 6th. So that is a product. So I can separate this first expression using the first rule I wrote over here into a summation. So I take the ln of the first factor, which is 4, and I add it to the ln of the second factor, which is x to the 6th. And I'm just going to bring this second minus ln of y to the 4th down. So I didn't do anything with this expression, I just brought it down. But I just separated this first expression into a summation using the first rule because I had a product of two things. Of the 4, let me use a different color here. The 4 should be my a, so that is contained in the first ln, and then the x to the 6th which is my second factor, so that gets contained in the second summation, second term. Okay, and then finally, if there's any exponents, we will use the third rule down here to pull the exponents out front, and it'll get multiplied. So the first one, I can't do anything else. That stays as ln of 4. But the second term here has an exponent of 6, so I can pull that 6 out front and multiply it by the ln of x, what's left. And then the third one, there's an exponent of 4 inside that ln, so I can pull that out front, so that'd be minus 4 times the ln of y. So that's me using the third rule. And then that's it. Once there's no exponents, there's no more multiplication, there's no more division inside the ln or the log, this is my final answer. Oops. Okay, number 20 says to solve the following exponential equation, express your answer as both an exact expression and a decimal approximation rounded to 2 decimal places. So this is a exponential equation because we have a variable in the exponent. And there's no way I could solve this by turning it into transforming it into its logarithmic form. But what I can do is take the log of both sides. So if you have an exponential equation, you are allowed to take the log, or ln, doesn't matter, of both sides, and it'll still be true. And so you can write this on there if you want. Now, after we take the log of both sides of an equation, we're going to use any properties that we just learned in the previous problem to finish solving it. So the first step is to take the log of both sides. So this would be the log of 7 to the negative 2x plus 6 power equals log of 528. Now what I can do, I'm going to make this a little smaller because this is going to be, I'm going to need more room. This first expression has an exponent. The entire negative 2x plus 6 is an exponent of that 7. So I can use that rule that allows me to pull that exponent out front. And because it's more than one term, I'm going to put it in parentheses. And then I can multiply it by what's left, which is log of 7. And I'm going to bring down the rest. Okay, now my goal is to get x by itself. So I need to distribute this log of 7 to both terms here because it's being multiplied by both of them. So I can do that. This will be negative 2x times log of 7 plus 6 times log of 7 equals log of 528. And now this is the only term that has the x in it. So I want to get that term by itself. So I'm going to subtract this entire term here, minus 6 log of 7. All that's being multiplied, the 6 is being multiplied to the log of 7. So it's just a number since there's no variables. So I can subtract that whole thing to both sides. It'll cancel on the left. On the right, this will on the left, that will leave me with negative 2x log of 7 equals log of 528 minus 6 log of 7. I can't actually subtract these yet without a calculator because they're not like terms, so I'm just going to leave it like that. You want to leave your answers in the log form until the very end. And then on the left here, I have negative 2 times x times log of 7. So it's all being multiplied. So if I want to get x by itself, I can do the opposite, which is to divide. And I can divide by negative 2 and log of 7. Because that'll cancel the negative 2 and that'll cancel the log 7. And that will leave me with just x, which is what I want. So this would be x is equal to log of 528 minus 6 log 7 divided by negative 2 log 7. So this is the answer for the first part here. And then it wants an approximate answer. So I can plug all this into my calculator. And I'm actually going to pull that up and show you how to do that. Let me take a picture. So if you don't have a calculator, a graphing calculator, you can always check one out at the library. At any FSCJ library. Okay, so I want to plug this whole thing into my calculator, and it was so if you press this green button, alpha, and then the y equals up here, it'll actually pop this up, and number 1 is a fraction notation, so you can just hit enter, and it brings up a fraction for you. And then there's a log button down here. So I type in log and then 528, close my parentheses, minus 6 log 7, close my parentheses, go down to the denominator, and that was negative. Anytime you start with a negative number, you need to use this minus down at the bottom. But if you're subtracting in between, you can use the regular subtraction. So minus 2, or negative 2, log of 7, close parentheses, and then hit enter. So we got 1.38916 ... So we go back. It says round to 2 decimal places. So this is approximately equal to 1.39. So that's the second answer for this part. Okay, so once you use that exponent rule, it's all about algebra. And you just need to know that the log 7 and the log 528, those are just numbers. So you treat them just like if it was just a regular number until the very end, using just the same algebra you would if that was just a regular number to get x by itself. Okay, number 21 says to solve the following logarithmic equation. Express your answer as either an exact expression or a decimal approximation rounded to 4 decimal places. Okay, so when you have a log equation like this, which is different from, what was that one we did? This one. Different from this one because there's more than one log expression. So for that one, we were able to just go straight to exponential form and then solve. But for this one, there's more than one. There's 2 logarithmic expressions. So now we need to use those rules that I listed here to condense them into one single log. So we're going backwards. That problem we have on the other page is being subtracted. So I'm going to combine them into one single log using division. So I'm going backwards. These work either way. So again, I have 2 logs being subtracted here. And so I'll write that rule here again. If I have log of A minus log of B, this is the same thing as log of A divided by B. And in this case, everything inside the first log, which is x minus 4, all of that will be my A. And everything in the second log, x minus 1, will be my B. So this will become log base 3. Make sure you keep your base here, because technically there could be a base in these. They have to be the same in order to use this. So in this case, 3 would be the C I just added here. And then inside, we're going to have x minus 4 divided by x minus 1 equals 2. Trying to use colors so you're not getting lost with where I'm getting this information from. Okay, so now that we have it all in one log expression, we can transform this to exponential form. So again, exponential form is if I have log base A of B is equal to x, then A to the x is equal to B. So that's going from logarithmic form to exponential form. So I start with my base of 3. I raise it to the power of 2. And then it's equal to everything inside. me use some colors here. Or actually, I'll use the same colors as I was using. So yellow was my base. Two in this case is my X. And then everything inside of that whole fraction is my B. So now I can solve this equation. 3 squared is 9. And to continue solving, I need to get rid of that fraction so I can multiply both sides by that denominator. And it'll cancel here. And then on the left side, I'm going to distribute that 9. So that'll give me 9x minus 9 equals x minus 4. Subtract x to both sides. So that leaves me with 8x minus 9 equals negative 4. And then add 9. So 8x will be equal to 5. And then divide both sides by 8. So x will be equal to 5 over 8. And if they wanted that as a decimal approximation, um, 5 divided by 8 is 0.625. (22) says to solve the following exponential equation, express your answer as a decimal approximation rounded to 2 decimal places. So anytime you see E here in an exponential equation problem, it's easier to use ln. You can use log still, but it's just easier to use ln because another property you can have on your cheat sheet is ln of E is equal to 1. And that's because if you remember, ln of E is technically equal to log base E of E. And anytime these are the same, the answer is just equal to 1. So this is important here. Another rule you can put on your cheat sheet is ln of 1 is equal to 0. But I don't think you'll use that one, but it's good to know. So we're going to solve this one just like we did this problem because we have a variable in the exponent. So we took the log of both sides on that problem in order to get the variable out of the exponent. But in this case, we're going to take the ln of both sides since there's an E there. And then we're going to use that exponent rule because I have ln of E to an exponent, so I can pull that exponent out front, which is 2x plus 14. Keep it in parentheses, and that will be multiplied by what's left, which is ln of E, is equal to ln of 130. And now, like I said, ln of E here is just equal to 1. So this is just becomes 2x plus 14 times 1. So that would just be 2x plus 14. So it kind of cancels. And this would be equal to ln of 130. And then I would subtract 14 because I'm wanting to get the x by itself. So this would be 2x is equal to ln of 130 minus 14, and then divide everything by 2. So then we can type that into our calculator. There's a button on your calculator for ln as well. So again, that fraction button, you hit the green alpha button and then y equals, and then hit enter. The ln button is down here. So I would have ln of 130, close parentheses, minus 14 all over 2. Hit enter. So that is equal to that decimal. And they want us to round to 2 decimal places. So that's negative 4.57. Okay, number 23 gives us 2 functions here, f of x and g of x, and they want us to find the formula for f of g of x and is that it? Oh, and then it's going to want us to find g of f. Okay, so first of all, this notation here, a lot of students mess up and think this means f times g. If it was f times g, they would just write it right next to each other like this. But that's not what that means. This means composition. So notation-wise, and you can put this on your cheat sheet, f of g, that's how we say that, of x, is the same thing as f. Well, actually, let me say it like this. The composition of f and g of x is the same thing as f of g of x. So this is notation. And what it tells me to do is it tells me to plug in g of x, so this function here, into f of x. Everywhere I see an x. So I'm going to replace that x in the x plus 5 with this entire g of x function. So that looks like x squared plus 3 plus 5. So I just replaced that x with my g of x. And I can simplify this by adding the 3 and the 5, so that would be x squared plus 8. So that's the final answer for the first part, for f of g. That's what would go right here. And then it asks about the domain of this function here. Well, there's no restrictions here on this function. There's no fractions, there's no square roots, and there's no logs. Okay. So because there's no restrictions, I can plug any number I want into 2x here. So the domain would just be from negative infinity to infinity. So as long as there's no restrictions on the functions, the domain will be all real numbers. And restrictions include fractions, and the restrictions on that is the denominator cannot be 0. Square roots is another restriction. The expression under the square root can't be negative, has to be positive. And the last restriction are on log functions. So the expression inside a log function can't be negative or 0. So it has to be positive. So these are the 3 restrictions you're looking for when you're asked to find the domain of a function. Also, I forgot to mention on this problem that once you get a solution here, you need to check your answer inside these expressions here and make sure it doesn't make the expression inside the log 0 or negative, but it won't. In this case. Wait a minute. Actually, it will. Actually, it will because of the x minus 1 here. So I did forget about that. So if I plug in x here as 5/8, so 5/8 minus 1, this is equal to a negative number since 5/8 is less than 1. This is negative 0.7 or negative 0.375. So this is bad because I cannot have a negative inside of the expression of my log. So actually the correct answer to this one, I'm so sorry about this, is no solution because it made that negative. So that's why you have to check those answers. I forgot to mention that. But this one's fine. There's no restrictions on an exponential function. So you don't have to check your answer. This one you do have to check, but that one made it positive, so we're good there. That was just expanding, so we didn't have to check that one. I'm just making sure we went over all that. Okay, and that one you didn't have to check. And I think I did mention... Oh, that was on the first midterm. That's right. Okay. All right, so we're good. So just be aware of those restrictions. You can put these restrictions on your flashcard if you want to, and just remind yourself that when you solve any equations with a logarithmic in them, you need to check to make sure your answer does not make the expression inside of the logarithm 0 or negative, because it's not in the domain. Okay, step 2 wants us to find g of f. So g of f, or the composition of g of f of x, is equal to g of f of x. So now let me remember those functions, rewrite them here. Okay, so here's my 2 functions. Now I am taking f and plugging it in to g. So whatever comes second here in this notation, that's what you're plugging into the first one. So I'm plugging that into g. So I'm going to take my f of x here, which is all of this, and I'm going to plug it into this x, into my g. So all of that x plus 5 will now become squared because the original x was squared in g. And then I will have the plus 3 on the outside. It will want me to simplify my answer, so I will have to FOIL this out, which will give me x squared plus 10x plus 25, and then bring down my plus 3, and then this will be x squared plus 10x plus 28. So that will be the answer to that first part. And then as far as the domain, again, there's no restrictions on this function. There's no fractions. There's no square roots, and there's no logs. So the domain will just be negative infinity to infinity. Okay, and then the last problem here, there will only be 24 questions on your exam. And I'm going over all of them, but of course they might change the functions or the numbers. It's just going to ask you to identify a graph. So this is supposed to be x cubed, sorry, not just x, but I'll go over both. So this goes back to the library of functions I told you about, so just make sure you're aware of those. And I even told you you could write this on your flashcard, so you could have all these on your flashcard. This goes on to the next page with all the options. But let's just go over what these graphs are. This first one is the basic linear graph. So that function is given by x. So if that was just x up here, you would have picked a. That's linear. There's no other exponent but 1 on a linear function. The second base graph here is x squared. That's a parabola, and the highest exponent is 2. So that's the base graph for x squared. This one is the square root function. This one is the cubic function. So this would actually be the answer you choose if it was x cubed, which is the one I said this was supposed to be. And then the next one is the cubed root function. This one is the absolute value function. And this one is the rational function, 1 over x. So those are your library of functions, the basic graphs that you should be aware of. This one shouldn't be on here. All right, so that's it. So again, you know, this is just a review. You should be reading the text and watching the videos before this, so you get an idea of how to do these problems, and I'm just reinforcing it. But of course, if you have any questions or need any more assistance, you can always email me and set up a virtual meeting with me before the exam day if you would like any more additional help. I'm going to be posting these notes and these videos for part 2. Thank you.